So chapter 3 starts out with some relatively simple things that we already know about, right? In terms of the mean, the median, and the mode of our data. Now, one of the things that we probably don't know is that these are all things called measurements or measures of location. And a measurement of location is a value that is used to describe the central tendency of a set of data. Now, we use arithmetic means primarily. It's our most popular, most commonly used measurement of central tendencies. So when we're talking about the arithmetic mean, another way to talk about it so specifically when we have a full amount of population data, we just call the arithmetic mean the population mean. So anytime you hear the mean without a modifier on it, it is defaulting to the arithmetic one, or the one that you are all used to. What does that arithmetic mean? So we use mu, lowercase mu, and this is just what we use for mean, right? That's just our term that we use for average. This is equal to the sum of all of my x's. So this large sigma here, right? This uppercase sigma is telling me the sum of, and then it's kind of opening a parentheses, so to speak. So the sum of all of the data that I have divided by the total number of data, the number of observations. And these are the actual observation values. So if I told you that, we had 4 people in the class, one person weighed 100 pounds, one person weighed 200 pounds, one person weighed 125, and another weighed 175, how would we calculate the mean for this, right? So each one of these would be an x value, x1, x2, x3, x4. Our n, right? We have 1, 2, 3, 4. Our n is equal to 4. So the way that we would take this data set and calculate the mu is we would have the sum of all of them on top. So we would do 100 plus 200 plus 125 plus 175, and then we would divide it by 4, giving us 150. Questions on population mean. So we have Greek letter capital sigma, which is denoting the operation of sum or addition. Lowercase mu is just what we use as the representative for mean. We're going to continue to use that throughout class. Uppercase N, always the number of observations. So in the book, we are told, we are given, so many exits on a highway. And it's a good kind of self-test to do as you're reading along with the book, or as you're going back through the notes or whatever. The important part with this particular example that the book talks about, right, is to kind of go back to our chapter 1 data, right, or our chapter 1 definitions in terms of, so if this was, so this is just 4 people in our class, right? So this would be a sample. So this actually is, not the best example because I said population mean, right? But this is our sample. And so let's say that this is going to be a separate elective that I have with just 4 students. If the whole class is 4 students and I have the weight of all 4 students, then this is our population now. So a population doesn't necessarily have to do with the number of observations. It has to do with the context of those observations, right? So if we have all the data for all of the possibilities, then we have that full population. And then this is the formula that we're going to use when calculating the mean. When we have a sample, things are sometimes different. So we have to keep in mind this distinction early on between the context of what we're looking at. When we have the full data set, so again, the book gives this example of, that there are, and instead of 42, let's just say there are, 5 exits through a highway, some interstate highway, and let's say in Rhode Island. And so since we have the information on all 5, right, we're given listed below are the distances between all 5 of those exits, right? And we're given, 11, 4, 10, 4, 9. And so calculating the population mean of this is going to be equal to 11 plus 4 plus 10 plus 4 plus 9 divided by 5, whatever that is. $38 divided by 5, 7.6. So the average distances between all of the exits on this highway in Rhode Island, so the full population, the average is 7.6 miles. So questions on just the distinction between population and sample. So we have to check the context before we state what the median mean is.
Is it okay if I ask a question about the sample mean equation, or should I wait for that?
Wait for that, because we're about to hit it. Yeah, that's why I said it's sometimes different, because in this particular instance, right, when we look at the sample mean, the sample mean is, instead of mu, we have x bar. And so these distinctions are going to seem arcane and sometimes minute, but when you say, you would be saying in English, the sample mean is, or you would be saying in math, x bar is, those say different things to the person who is reading that statistic or is interpreting that statistic or is listening to you when you're talking about that statistic, if that makes sense. So the formula is going to be the same. We're still going to have a sigma of our x's. We're still summing all our x's, and we're dividing by, and this time we're dividing by lowercase n, where lowercase n is the number of values in the sample. X's are just the values. And so one of the things that I did in elementary school, the Chips Ahoy packages said that there were like 1,000 chocolate chips in each package or something, right? That was some claim that they made. So we took, 20 boxes of Chips Ahoy cookies and dissolved them all and counted the number of chocolate chips in each one. That was a sample of the total population, right? That was only 10 of the bags of Chips Ahoy of the millions of bags of Chips Ahoy that were produced that year. But from that, we were able to calculate the average number of chocolate chips and figure out that, yeah, there is more than 1,000. They weren't lying. So oftentimes it's too expensive, or it's just plain not feasible to get the data on the full population. Sometimes you don't know the full population. Sometimes you can't reach the full population. A lot of times. Does that answer your question?
I was thinking of a different equation.
Okay.
I was wondering why population variance is divided by n, but sample variance is n minus 1. We'll get to it.
Yeah, we'll get to it. Okay. So the next one, which, again, is going to be review for a lot of people.